Alright, boys and girls, welcome back to the drive-thru for a little sick Barry Manilow version as my voice tries to keep up. I'm doing my best here. Maybe you prefer Carson's voice. Click on over and watch his version. He did an awesome job on this section. Okay? Most of this video is going to be about solving equations. Notice that each equation is kind of similar, but this one has an extra variable. So when we solve some of these, we are going to have it in terms of another variable. That's kind of the goal of the lesson. Okay? So, I'm not a big fan of fractions, so I'm going to multiply that by 5. I have to multiply both sides by 5. That gives me 3x plus 2 equals 35. Okay? Subtract 2. 2's are gone. You get 3x is 33. Divide each side by 3 to get that x. 3 times 11 is 33, so x must be 11. Now, let's do this one very similarly. Multiply both sides by 5. 3x plus 2y equals 35. You always got to keep in mind what we're solving for. The directions tell us to solve for x. So we need to get this by itself. So now we are going to subtract 2y, which gives us 3x equals 35 minus 2y. We're solving it for x. X is being multiplied. How do you get rid of multiplication? You divide. 3 divided by 3 is 1. And that gives us x equals 35 minus 2y divided by 3. Notice the answer is in terms of y. Okay? Alright, for this one, well, I could multiply both sides by 3, but I'm going to get rid of the fraction a little later on this one. Remember, we are working, please excuse my dear Aunt Sally, backwards. We're taking it backwards. So I'm actually going to get rid of the addition and the subtraction first by adding 5 to both sides. Negative 5 and positive 5 is 0, so that one's gone. 4x over 3 is 16. Multiply both sides by 3. 16 times 3 is 48. Divide both sides by 4. And you get x is 12. Check my answer. 48 divided by 3 is 16. 16 minus 5 is 11. I know I did it right. Alright. So this time, I'm just going to give myself a little bit more room. 4x. I'm just rewriting the problem. I'm going to add, this is the dumbest, I'm going to add 5y to both sides. Negative 5y and a positive 5y is gone, leaving me 4x over 3 is 11 plus 5y. Okay? Let's see, now I'll multiply both sides by 3. Get rid of the division. You get 4x. I got to remember to distribute. 33 plus 15y. Divide each side by 4. X is 33 plus 15y divided by 4. Moving on. Okay, notice these are similar again. So let's multiply, instead of distributing the fraction, let's multiply both sides by 5. And while we're at it, let's divide each side by 2. Maybe you would do that in 2 different steps. That's totally fine. But I want you to know that cancels the left side, and that gives us x plus 3 equals 30 divided by 2. 30 divided by 2 is just 15, so always make it as simple as you can. Now we're going to subtract 3. And you get x equals 12. Okay? So, let's do a similar thing. Multiply by 5. Divide by 2. You get x plus y is 30 divided by 2, so that's 15. We're solving for x, so we are going to subtract y, and you get x is 15 minus y. Okay? Okay, 7 and 8. 2 different ways you could do this. Now, it would make sense to distribute. We don't have any fractions. So I'm fine with that. Just call it 6x plus 8. Get rid of the parentheses. Now we just have a nice, simple 2-step equation, or 3-step equation maybe. So we're going to subtract 4x. 4x minus 4x is 0. So here we have 2x plus 8 equals 12. Subtract 8. And you get 2x equals 4. Divide each side by 2. And you get x equals 2. Okay? Similarly, over here, I'm going to distribute 6x plus 8y equals 4x plus 12y. Let's get rid of the 8y from this side because we're solving it for x, so we're going to subtract. If this thing will let me make a subtraction sign. 8y minus 8y is 0. Whoops. So 6x is 4x minus 4y. Sorry, plus 4y. Plus 4y. Okay? Divide each side by 6. And you get x equals, well, I would take this as a correct answer. I'd be fine with that. But both of those things, everything on the top and the bottom is even. So if we divided by 2 over 2, we could get x equals 2x plus 2y over 3. Not simplifying your answers is not the biggest deal to me. Okay? All right. So first, I would add d. That gives us ax plus b over c is e plus d. Then I would multiply by c. Let's go ahead and distribute CE plus CD. If you wrote yours in a different order, like if you wrote it EC plus DC, that'd be fine too, whatever. Alright, now we would subtract B from both sides. So they just want you to write out what I'm saying, giving you AX is CE plus CD minus B. Divide everything by A because we're still solving for X. And this is the answer. X is CE plus CD minus B divided by A. That's about as complicated as you could get. Okay, let me rewrite this one over here. We're still solving for X. R times the square root of mx over n plus s is equal to t. Well, remember, I'm still doing Pemdas backwards. So backwards. So I'm going to get rid of the multiplication before I get rid of the square root. So I'm going to divide both sides by r. And you get square root of m x over n plus s is t over r. Alex, how do you get rid of square rooting a number? You have any idea what the mathematical opposite to square rooting a number is? It is squaring a number. Very good. Okay, what is the square root of 25 squared? It's 25. You go down to 5 and back up to 25. What's the square root of 9 squared? It's just 9. Okay, so it's just their inverse operations. So when we square this, those things cancel each other, giving us the circle of death, mx over n plus s equals, well, this is just t squared over r squared. If you left it like that, that'd be fine. Now, Pemdas backwards. So I get rid of addition first by subtracting. So you get mx over n is t squared over r squared minus s. Multiply both sides by n. And then while I'm at it, I'm going to divide both sides by m. And this is trickier than anything I'd ask you to do on the test. This is accelerated math at this point. But don't stop yourself from believing you could do accelerated math. You just need the time. T squared over r squared minus s, the whole thing multiplied by the fraction n over m. I believe that is the last one. I'm here right now with Alex Schindler. I believe it might be his birthday. Hey, everybody say happy birthday to Alex. He wants to give everybody a boom.